Welcome and thank you for standing by. Currently, all participants are on a listen-only mode. Today's webinar is being recorded, and the recording will be posted publicly. If you have any objections, you may disconnect at this time. Now I'd like to turn the call over to your host for today, and one of your presenters also for today, Vicki Mack.
Thank you. Hello, everyone. Thank you for joining our session on creating American Community Survey Maps with R. My name is Vicki Mack, and I work in the American Community Survey Office at the U.S. Census Bureau. I'm here with my coworker, Jessica Klein, who works in the Economic Statistical Methods Division. I'd like to remind you that today's webinar is being recorded. If you would like to follow along with our webinar, we have posted the slides at the link you see here. The link to the slides will be or may already be posted in the chat. A recording and transcript will be posted on our website within the next few weeks at this same link. If you have any questions during the webinar, please post them in the chat section, and one of our team members will try their best to respond to you as quickly as possible. At the end of this webinar, we will also verbally answer some questions that may have been missed in the chat. For today's webinar, I'll provide an overview of the American Community Survey, or ACS, and the data it provides. Next, I'll discuss some of the Census Bureau's tools for mapping ACS data and the pros and cons of using R as a mapping tool versus these other tools. Then I'll explain tools you need to get started with mapping ACS data in R, including the Application Programming Interface, or API, and the R packages and functions. After that, Jessica will demonstrate how to map ACS data in R. Finally, I'll share resources for learning more about R and ACS data. The ACS is the premier source of detailed information about the nation's people and housing. The survey samples approximately 3.5 million addresses each year and 150,000 group quarter residents. These data are collected continuously throughout the year to produce annual social, economic, housing, and demographic estimates for communities throughout the 50 states, DC, and Puerto Rico. The estimates cover more than 40 topics. The ACS collects this detailed information each year that was previously collected by the decennial census each decade. Information from the ACS generates data that help inform how trillions of dollars in federal funds are distributed each year, supporting more than 300 known federal uses and countless non-federal uses. ACS data are timely because they are released the year immediately following the year in which they are collected. The ACS creates period estimates, which mean they represent the characteristics of the population and housing over a specific data collection period. The ACS releases estimates for 1 year and 5-year periods. After years of extensive testing, the ACS was fully implemented in 2005. The first ACS 1-year estimates were collected in 2005 and released in 2006. The first 5-year ACS estimates were collected between 2005 and 2009 and released in 2010. The ACS collects data across 4 key categories: social, economic, demographic, and housing. Social characteristics include topics such as education, language spoken at home, and veteran status. Economic characteristics include such topics as commuting to work, employment status, and income. The ACS also collects basic demographic characteristics such as sex, age, race, and Hispanic origin. Housing characteristics include topics such as computer and internet use, housing costs, and new topics added in 2025: electric vehicles, solar panels, and public sewer connectivity. Data for these new topics are planned to be released in 2026. These topics are used to produce more than 1,000 tables for local communities each year. The ACS also provides data for more geographies on an annual basis than any other household survey. The image on this slide shows some of the geographies for which ACS data are produced and the relationship between them. Lower geographic areas fit neatly within the larger areas directly connected with lines. For example, school, congressional, and state legislative districts fit neatly within states and do not cross boundaries or do not cross state boundaries. However, they may cross boundaries of counties or metropolitan areas. In this visualization, you can see the smallest geographic building block is the block group. Block groups are a group of blocks within a census tract with about 600 to 3,000 people. Right above block groups are census tracts, which are small statistical subdivisions within a county with populations of 1,200 to 8,000 people. ACS data products are released about 1 year after the data are collected. The Census Bureau applies population-based thresholds across geographies in the ACS tables to determine whether they can be published as 1-year estimates, 1-year supplemental estimates, or 5-year estimates. ACS 1-year estimates, which combine data collected over 12 months, are available for geographic areas with a population of 65,000 or more. 1-year supplemental estimates are available for geographic areas with populations of 20,000 or more. 5-year estimates combine data collected over 60 months and are available for geographic areas of all sizes down to those granular census tracts and block group levels. The full detailed data release schedule for each year is available on the data releases page. The data are typically released in September, the calendar year after collection as 1-year estimates, in October, the calendar year after collection as 1-year supplemental estimates, and 5-year estimates are generally released in December, the calendar year after collection. For example, the 1-year ACS data collected from January 1st through December 31st of 2024 were released in September of 2025. The Census Bureau provides several tools that allow you to map data. For example, quick facts, data.census.gov, and several interactive maps allow you to visualize data in map formats for many geographies. Data.census.gov is specifically designed to provide ACS data and allows you to map the data from thousands of ACS tables that are available. These tools are great, but we will explain why you may want to try mapping with R instead next. Census mapping tools are user-friendly and no code is needed for mapping the census data. Plus, you only need an internet browser to use these tools. On the other hand, R requires a steeper learning curve and familiarity with the R language and its mapping tools. You also need to install R on your computer. Census tools are ideal for quick one-off data pulls and mapping. But here is where mapping with R has a major advantage. With R, you can create reproducible workflows. That is, you can write code once and easily update it for any year or geography. Basically, the main reason you will want to try R instead of the census mapping options is that you want more flexibility in mapping census data. For example, you can create new estimates and map those new estimates in R. You can also create your own custom geographies and map the data for those created geographies. Can't do that when using census mapping tools. Before we discuss mapping with R, I need to explain what R is. R is a free, open source computer language used for mapping data. It helps people clean, explore, and analyze information, especially large data sets. R is widely used in research, government, and industry because it can handle statistics, modeling, and data visualization. It has a large community that creates add-on packages, making it easy to extend R for nearly any type of analysis. And R works on all major operating systems and can be used through a free user interface called RStudio or other development tools. The maps on the screen were created using R. They show how creative you can be with maps created in R. To begin mapping ACS data in R, you first need an application programming interface or API key. Now, the API is the free public tool that allows developers and researchers to query and download statistical data directly from Census Bureau surveys. You only need to request the API key one time. An API key is a free, unique string of characters required to access U.S. Census Bureau data from the API. Users must register for their API key on the Census Bureau's developer site. Until recently, an API key was only needed if you are requesting 500 requests per day per IP address. Now it's required for all queries. The API key enables developers to integrate census data sets, such as the ACS, directly into apps, websites, or analytical software. Once you have a key, you can use the R function in the tidycensus package to save your key to your computer's environment file. That way you don't have to enter it manually for every session. I'll talk about tidycensus in a moment. You will have to sign up for an API key at the link shown here. You can also learn more about the Census API by watching the recorded webinar at the link on the bottom of the screen. Before you go searching for ACS variables, you also need to understand the different ACS data products. They are where R will get the variables needed for any analysis or mapping. The Census Bureau offers pre-tabulated tables and profiles. Tables provide a precise or detailed view of a subject. They are the best source for the most comprehensive ACS tables. From tables, you can choose from the detailed tables and subject tables. Profiles, particularly data profiles, are a good place to start when exploring data for your community or area of interest, as they contain the most frequently requested social, economic, housing, and demographic data in a separate profile, providing both estimates and percentages. The profiles can choose variables from the data profiles and comparison profiles. The prefixes for tables are letters B or C or S, and the prefixes for profiles include DP and CP. Now let's discuss ACS variables and how they show up in the API. Here we see two API variable IDs from the detailed table B17001. On the left of the image are variables B17001 underscore 002E and D17001 underscore 002 M. There are three elements to an API variable ID for ACS variables. They are the table ID, the line number, and the annotation. B17001 is the table ID, which is, in this case, is for poverty status in the past 12 months by sex, by age. On this table screenshot, to the right, you can see the table ID outlined in red on the top left. You can tell this is a detailed table from the B at the beginning, or the prefix. After the table ID, we see the row number after the underscore, in this case, 002. This tells us what row number we are pulling from the table. Each ACS variable in the API has a specific row number that shows where it fits in the table. Row number 2 in this table is the population with income in the past 12 months below the poverty level. This is shown in the bottom box outlined in red. Finally, we have the annotation, which tells us what part of the variable we are seeing. We have the variable ending in E. We are asking for the estimate. In this case, the number of people with income in the past 12 months below poverty. The E tells us to pull the variable from the estimate column. We can also get the margin of error by asking for the same variable, but replacing the E with an M, which tells the API to grab the variable from the margin of error column. We can see these column headings in the middle box outlined in red. There are some more annotations within other ACS data products, such as the data profiles. These annotations include things like P for percent estimates. You can see how this table looks on data.census.gov by following the link on the screen. Next, you need to know which R package to start with. To get started with mapping ACS data, you should load the tidycensus package along with the tigris and tidyverse packages, and then set your ACS or set your census API key. Again, an API key is required. The tidycensus R package simplifies the process of acquiring and working with the U.S. Census Bureau data. It provides a direct interface to several census APIs, allowing you to download data directly into R without having to manually download files from the census website. The tigris package in R is designed to let you directly download and use the tiger line shapefiles from the U.S. Census Bureau. And tidyverse refers or returns data as tidy data frames, making the data immediately ready for analysis. To be clear, these packages are not provided or supported by the Census Bureau. To learn more about these packages, visit the Walker website link at the bottom of the screen. Now, if you're not sure what ACS variables you can or want to map, you have a couple of options. You can search the Census Bureau's API tool to find variables at the link shown here. Now, that's one option. You can also use the load variables function in R to select the ACS dataset and year. For example, you may be looking to map income data from the 2025 5-year estimates. When you call load variables, it returns the ACS dataset and year. Then you can use the view function in R, which allows you to filter and search variable labels like income or rent to help you find the exact variable code you need. The view function in R is a built-in function that allows users to view the contents of data structures interactively in a spreadsheet-like format. Third, you need to know how to fetch census data, specifically ACS data. To do that, you would use the get ACS function in R. The get ACS function is from the tidycensus package and is used to download data directly from the ACS via the API. The R code example shown here on the right was used to download data for Villa Rica. Villa Rica is a city which straddles the line between Carroll and Douglas counties in Georgia. Let's go through this example of fetching your data. Now, the get ACS function, which is get underscore ACS, is the workhorse of your script. The other key arguments include these listed here, starting with the geography argument. The geography argument allows you to select a geographic area like a census tract, a county, or state. Variable refers to the census variable ID, like the example shown here in table B19013. That variable ID is B19013 underscore 001. County specifies the county or counties which you need for mapping census tract data. The R code snippet is a perfect example of how tidycensus handles cross-county geographies like that for the city of Villa Rica. Geometry equals true is a crucial part of the code. This tells R to download the map boundaries along with the data. Year refers to the vintage of the data, and output equals wide refers to a format where each subject has a single row and repeated measurements or categories that are spread out into multiple separate columns. Now here's a quick tip. To fetch the data for the entire table, I changed variable equals B19013 underscore 001 to table equals B19013. Now that we've covered some basics, I will hand the webinar over to Jessica to demonstrate some examples of mapping ACS data in R.
Hi, everyone. So one of the things that I enjoy most as a data scientist at the Census Bureau is seeing the many ways people use our data to answer questions and tell stories. The good news is the Census API makes a lot of this data available to everyone, making it easy to start your own exploration. In this demonstration, we will take many of the concepts you learned about from my colleague Vicki and put them into action using the R programming language and R Studio to retrieve data and create maps using the Census API. I've also shared a GitHub repository that contains all of today's materials, which is what I'm sharing here. GitHub is a platform for storing and sharing code and project files, making it easy to access the examples, revisit the workflows, and continue practicing independently. If you are generally new to R and need help getting started, you can go about halfway down and follow the steps on how to download all of the tools that you need, download this repository and get it set up on your computer so that you can use the code and follow along and start practicing. If you would like additional practice after the session, I've included 2 practice files. One focuses on working with the Census API to retrieve data, and the other focuses on retrieving shapefiles and geographic boundaries. So while this demonstration uses real data, the analysis and examples shown are for demonstration purposes only. The views and interpretations expressed here are my own and do not represent the official positions of the Census Bureau. So now I've switched over to R Studio. And for today's session, there's really 3 areas to focus on. The setup file, which you can find in the setup folder, and that's going to allow you to install all your packages, load those libraries, install that API key, and give you a practice example to test and verify that you're able to connect to the API and get ACS data. The 2 example workflows that we're going to work through can be found in the demos folder. So these are the 2 that you're going to see me and you're going to follow along with, and you're going to see this example of connecting to data, connecting to shapefiles, bringing them together, and creating a map. Afterwards, the practice examples that would be helpful for you to follow along with and practice and give you the skills needed to start independently connecting to the API and getting data can be found in the examples folder. One is meant to help you connect to the API, and you can change all of the arguments, you can change the geographic levels, the variables, and get some practice there. And the second gives you the opportunity to practice different shapefiles, connecting to them and bringing those shapefiles into your session. So we're going to start with this setup file, and it gives you everything you need to install your packages. So please follow the directions. You would uncomment these following lines and install the packages. Load your libraries, and then on this line, you'll load your Census API key. You would uncomment here. If you do not yet have a Census API key, you can follow the link included or the one that's in the slides, and it should quickly come to you. Once you activate it, you can insert it here, run this line of code, and it's going to be installed into your environment. Once you've completed these steps, you can test to verify that you're able to connect to the API with this ACS test code. If you get data back, which we have here, then you know that you've successfully connected to the API and that you're ready to go with the rest of the demonstrations. Before we move into the demonstration though, I'd like to show you the URL that we're connecting to. This show call and true argument is telling the get ACS function to give us back the API call so that we know what we're connecting to. This looks very familiar. We see that we're connecting to a state geography, and we can see that embedded in this URL. We can find the variable that we're connecting to, the year. And then while many of us might be new to the API, we're not new to URLs. So if you can start to connect how your arguments are setting up this API call, you'll be more successful as you're diving through the different options, and you can figure out what variables are really going to suit your purposes. So with that, we're going to move into our individual examples. I'm going to be showing R Markdown here because that's a really nice way for an R to keep presentation code and output together. But when you're running this independently, you're going to want to use those .r files, which are in our demos folder. So before we move to our individual examples, we're going to start with a simple 3-part workflow so that you can see the pattern of connecting to our data, getting our shapefiles, putting them together, and creating a map. And that's really all there is to it. Once you have that pattern down, you'll have access to everything. And there's a whole wealth of information on there. And we're going to see all of the different endpoints and variables you can connect to shortly. So first, we're going to load our packages. We did that in the setup, but if we went away from our session, if we turned everything off, we'll have to reload them. We have a few settings that we're setting at the beginning, but the most important part, the part that starts off our workflow, is deciding what variables do we want to connect to. So for this first example, we're going to connect to travel time to work variables, and we're going to specifically focus on longer commute categories. Our universe for this specific demonstration is going to be workers 16 years or over who did not work from home. These variables are ACS variables that correspond to this table, and you can see that there's ranges. So we're going to take all of those longer commutes, 30 minutes all the way up to 90 plus, and we're going to visualize those categories along with our total workers. And this is a list that we're going to then pass as an argument to our get ACS function. So you remember Vicki said that this is the powerhouse of tidycensus. This is what's going to set up that API call so that we can get our data back. From there, it's as simple as setting our geography, in this case county. What variables do we want? We pass that object that we recently created with our list of variables. We want the 2024 data from ACS5, and notably ACS5 is the default. So if you want ACS1, you have to change this from 5 to 1. And then we're going to look at that wide output. We're also going to include show call true, because again, I think that helps people connect to what data are we bringing down into our session. For this example, we're just creating a quick calculation using mutate, and we're going to create a commute index that is the approximate weighted commute burden score. Again, this is just a calculation only for demonstration, and it's going to help us visualize using a single data point with real data. A second data set we're going to get for this example is population place level data. So putting these examples next to each other, you can see that they're structured very similarly, if not the same. So we're still using that get ACS function, but we've changed our geography from county to place. Our variables, we're specifying just one variable for this example, and that's total population. Still, we're sticking with 2024 and ACS 5 and keeping our show call. From this data set, we're only going to keep GeoID and we're going to rename estimate to population. Putting them side by side, you can see how they're very similar and how you can start to make adjustments so you can change geography, variable, year, and what survey are you connecting to. This is the first step of our workflow, is connecting to the data and bringing it into our session. This is just a little preview of only 10 rows of that commute ACS data. You can see that we have a GeoID column, and this is going to be very important for the next step. We have our county and state names, and then we have all of those variables that we asked for, total workers for our universe, and then we have our M, margin of error. So every ACS variable is going to come with its estimate and margin of error. If we scroll to the very end, we can see that commute index that we calculated, and that's going to give us one single visualization point. After we've successfully gotten our data, it's time to retrieve our shapefiles. So because we're going to do multiple exercises, I'm going to get multiple shapefiles. But again, looking at them together, you can see how structurally the functions are similar. In this first, we're going to look for the county level shapefiles. We're going to, CB True gives us a generalized shapefile, which is going to be a little bit smaller, better for space. And then we're looking for the year 2024. We want to keep all 50 states and Puerto Rico. And then we're going to shift our geometry. So I'm going to highlight that a little bit more in our second run through, but the shifting geometry is just going to change the view so that it looks more appropriate for reports and publication. So first we're getting our counties, then we're going to get our states, very similar structure, and then we're going to get our places. We're doing a few more calculations using the tidyverse. We're mutating to create an area, a geometry area, and then also we are splitting our FIPS. Then we're going to create a list of our US capitals. And we're going to do a few more transformations, and that's going to give us a few layers that we can visualize and map. Now that we have those county boundary geometries, we can map our commute estimates. And this is what a shapefile looks like. So the data files are strictly data files. They're data frames, they don't have geometry. Shapefiles are unique in that they are simple feature collections. They have a geometry associated with them. They have a coordinate system and bounding boxes. So latitude, longitude, and this geometry column is what allows us to build those maps. Remember I said that GeoID column is very important. When you're bringing the data and the shapefiles together, you need a common linking ID so that you can bring them together for that visualization. So now that we've got our shapefile, we can join them together. Using left join, we are going to attach our commute ACS object to our county's simple features object by that GeoID column. So now everything's been brought together nicely. And this is just like, again, a little preview of what that data looks like. We have our state, our county name, that commute index score that we calculated, and our geometry. And now we know that we're in a great place to create a map. We have more columns available too. So say we want additional layers, we want to do another transformation. We have a lot of good information here, and it's in a geographic shape that we can create a map from. This is optional. We have a official census blue color, so I like to have this census style blue palette, but you can use whatever color styles you want or the ones that are built in by ggplot. Now that we've done all that work, we can start mapping. So again, all we needed to do to get to this point was connect to our data, bring it down, connect to our shapefile and bring it down, put it together, and now we can put all of that information into a great map. For this first example, we're going to look at the county level in the commute index calculation. Going down, this is our first map of the day. This is all of that commute index calculation data that we put in a geographic shapefile along with state capitals, and major cities. So we can start to look at patterns of commuting close to these major city centers. And at first appearance, it does look like a lot of the darker, longer commute areas are close to these cities. So this is our first mapping example. And again, the workflow was get the ACS data, create that commute index, get our county shapefile, our state capitals and major cities, join it all together, and create a map. If you can remember that pattern, you will be successful with connecting to the data and bringing it down to work with. For our second example, we're going to explore commute patterns in a targeted area. We're going to look at the Washington, D.C. area. So rather than going broad, we're going to look at a specific area. We'd like to filter our geographic data down to a smaller zone and view regional commuting patterns using county-level ACS estimates. To do this, all we have to do is filter that county map by our state FIPS code. And we're saying that we'd like to keep Washington, D.C., Maryland, Virginia, Delaware, West Virginia, and Pennsylvania. Looking at a preview of this, we can see that we have this smaller subset of data, and that's going to allow us to have this smaller level of visualization. We're going to build our visualization with ggplot. And then now we're able to only focus on the states, regions, etc. that we want to look at. So you can take these larger shapefiles and filter them down so you're looking at areas that interest you. For our third example of the commute data, we are going to calculate a weighted mean commute time and visualize the results at the state level. So once again, we're going to go back to our beginning step, and we are going to connect to ACS to get a full table's worth of data. We want to get all of the commute variables. Remember at the beginning, we only focused on 30 minutes and longer. Now we'd like to look at all of those categories. So we're going to specify state level geography. We want all commute variables at the 2024 vintage for ACS 5. We want our output to be wide, and again, we're going to show call true. We're going to define midpoints for each commute variable because remember, they're a range. So this is when you can start getting into custom calculations that work for your analysis. For this one, I want midpoints so I can create a score. I'm going to then compute the mean commute time using these midpoints. And now I have a average commute score for each state that I can visualize. So I now have 1 point for my mapping. I'm then going to get those state level shapefiles and I'm going to shift the geometry. So I'm going to get states at the 2024 year. We're going to join our data and shapefile with a left join, and we now have everything linked. To look at our full list of columns, we have all of our commute variables. And we now have that data and geography linked. We have our name, we have that average commute score, and then we have the geometry. So as long as we have data, geometry, and a name, we're able to create a map. And then here is our resulting visualization. This is the weighted average commute time across states. So this example demonstrated how we could take one variable and visualize it at different geographic levels and create calculations with it so that we have one data point to visualize. Now we're going to move into a second set of examples that are smaller and are going to help emphasize that workflow of connecting to the data, getting the shapefile, and we'll show a few different examples on how to do that, putting them together and creating a visualization. As long as you can remember that mental model, you will be able to use all of the resources that Census puts out for you to be able to explore different endpoints, different variables, and different years. So again, we always start with loading our packages, but if we did that in the current session, we don't need to do it again. And let's first take a look at the available data sets. This is just a little preview, but I'm going to show the view. And you can see that there's 1,788 census endpoints for you to connect to. So we have current population survey, ACS, all sorts of great data sets to dive into and look at. And they all have different variables, different levels of geography, lots of great options here. So once you start exploring and you dive into which you pinpoint which data set you'd like, you can remember that URL, and this is also going to be a great page to give you more documentation. Additionally, at the very end, if you run into any problems, there is a contact you can ask more information from. So if you have questions about a variable or documentation, you can reach out to that program area. So once you've decided which API you'd like to look at, you can also filter down to a specific topic. So we know we would like to look at ACS in this example. So I'm going to filter that API data frame into a smaller ACS-centric data frame. We have 29 unique ACS-related API endpoints to connect to. You can see all of those examples here. They're also here to dive into. You can look at the URL and then who you need to contact for more questions. There's also, as Vicki mentioned, data available since 2004. So there's a lot of great information waiting for you to connect to. You can make time series, you can make all sorts of maps with this data. And then if you want to look at the available variables within a data set, you can use that load variables function. And then I'm just going to show a little example of the different options. This is just a tiny little subset of information. And then these are the variable names, their descriptions and labels, and then the concept. So if you do a view with these objects, the whole thing will open up and you'll get to explore and really dive into what options you have. I believe when I looked at this earlier, there were over 17,000 variables. So you can imagine there's a lot of opportunity in there for some great maps. So once we've explored our options, we can start by mapping state population estimates from the ACS. So our goal is to retrieve ACS 1 year 2004 population estimates, join them to state boundaries, and create a heat map using ggplot2. So I showed you those websites earlier. You can also use these with the survey you'd like to connect to, the year, and you can look at the different geography options you have and the different variable options you have. And sometimes these are a lot, I won't say easier to navigate, but they give you a different type of navigation than if you're doing that within RStudio. Now let's first make that data call, and we're going to look for the state level geography. The variables we want to bring are total population, male population, and female population, all estimates, for 2024 from ACS1. Again, get ACS defaults to ACS5, so we would have to specify ACS1. And we can see that the data we bring back. So before we were bringing back wide data, and that's when it's more columns than rows. In this example, it defaults to long data. So that means everything's stacked. You can see we have Alabama, all three of our variables, the estimates, and the margin of error. So this is going to be the backbone of our visualization. This is all of our data. Next, we're going to get those shapefiles from Tigris. So we're going to get the state for year 2024. It's not mandatory, but it's good practice to get the same year shapefile as you have data. And then let's just look at a little preview of that shapefile. Again, we have a simple feature collection label. It's a multi-polygon. We have that bounding box. These are all good signs that we're able to visualize and map this data set. Without this, it would not be a geographic visualization. It would be a bar chart, a scatter plot, but these are the details you need to create a map. And then here's our multi-polygon. We're going to put them together with a left join. Again, you need to have a common column. In this case, GeoID is almost always going to be helpful. We have our FIPS codes. And going back up, we have our GeoID FIPS codes. So that's going to bring the data together. And then this is just a little preview of everything in one place. And then we can visualize it. We can create our map with ggplot. So note that this is this is that standard shape file. It's this, but it's not the census standard view. So we like to have everything formatted nicely. Alaska, Hawaii, and Puerto Rico are going to be brought into the United States so that you don't have all that white space around. But it's important to note that this is going to be the default view when you get a shape file. That's where shift geometry comes in, and we're going to see that in a subsequent example. But you've accomplished the basic workflow. We've gotten our ACS data, our state shapefile, we've joined them, and we've created a map. And you can see a little bit more information about those geographic shifts in the documentation. Now, before I show that shift geometry, let's have an example where we create an interactive map that allows you the option to zoom, pan, and inspect population estimates for individual states. This is going to look very similar. We're taking still the state level, all of our total population, male and female, and then looking at year 2024 ACS1 wide output. So map view really likes wide output, whereas ggplot really likes long output. So you can see that wide, we have more columns instead of stacked. Then we can join it to our shapefile, our state shapefile, and our population. And then we can use map view for an interactive visualization. And map view is cool because you have a lot of control over the customizations. Going down. So now we have an interactive map to preview. So you can hover over tooltips. This really nice interactivity gives you the ability to see your total, your breakdown total males and females. And very uniquely, the interactivity can be retained in HTML. So the HTML files have been included in that RMD folder, and you can share with others and maintain that interactive visualization. So this is the rendered HTML from the R Markdown. I'm going to go back to RStudio and we can go back to our demo. So those are two visualizations options you have. Our next example is going to include that shifted geometry. So we're going to retrieve the ACS data with geometry included. So up until now, we've been getting our geometry separately so that you can see how to get a shapefile. And there's so many different shapefile options that it's worth exploring. But for this instance, we're actually going to set our geometry argument to true. This is going to bring that geometry in during the data call, and tidycensus makes this possible. Because of this, you do not have to go out and get that shapefile anymore. This will give you the geometry directly within your data. Then we can create our visualization, and you can see the difference that shift geometry view gives us. Alaska, Hawaii, and Puerto Rico are now brought in closely, and it looks really nice. So this is something that is really helpful if you are creating maps that you want to put in reports or other views where everything is going to be formatted in a nice closed space. I have a decennial example, but we're going to, for the interest of time, skip over this one, and we're going to move to our next ACS. But here's an example of county population counts from the 2020 decennial census. So tidycensus makes it easy to get decennial and ACS data alike. Let's look at our next example, and this is where we're going to map county level poverty rates in the Mid-Atlantic region. So following our pattern from earlier, we're going to set our geography to county. We're going to ask for this variable, and that's income in the past 12 months below poverty level. And then we're going to specify which states we're looking for. So instead of all counties, we only want counties in these states. We want 2023 data this time, so we're going back a year from ACS 5. We can then get the county shapefile from 2023. So again, we're able to keep that consistency, and we're going to shift our geometry to the object directly. So now you've seen 3 different ways to get geometry, geography, shift it, and make sure that it's included in your data. Let's then join that data with the shapefile and create our visualization. So now we have a more narrowed looking view of our county shapefiles. Instead of all states, we can look at just a few states and all of the counties. Similar to our past example, we can also create an interactive map with it. as such. So this interactive map, you have a lot of control over the tooltips, the customizations, the formatting, etc. And it gives you this really nice overlay on top of OpenStreetMap, which is another open source package or open source platform. You can zoom in, you can do all sorts of great things with this. And we're just reinforcing that workflow, right? Even though it's a smaller group of states, a smaller set of counties, we still have to connect to our data, get our shapefile, put it together, and then create our map. So I'm going to go to one more example. As you can see, there's a lot of great things for you all to use to run independently, to change the arguments for if you want different variables, different years. But I'm going to go all the way down to my very last example. And we're going to look at overlaying more than one shapefile. So in this example, we're going to use getACS to get tract level data for Washington, D.C. The variable we're going to connect to is the median household income in the past 12 months, and we're going to get the geometry directly. We're also going to get a landmark shapefile. So Tigris has a lot of great options. You have school districts, waterways, rails, landmarks. There's a lot of unique shapefiles that you can connect to create visualizations with those interesting pieces of data. I mean, this is all of the major landmarks in Washington, D.C. and the median household income of the areas surrounding it. So again, I've showed many examples today, but our workflow stayed the same. Get the data, get the geometry, put them together, and create a visualization. And if you have that down, you'll be able to do this as well. I would suggest you keep exploring using the example files for practice. So you have one that will allow you to practice different API calls, many different API calls, and then one that will let you practice different shapefile calls. So at the block groups, tracks, ZICTAs, places, etc. And there's a bunch of examples at the end where you can put it together with data. So I hope you enjoyed this webinar. I'm going to pass, or this demonstration, I'm going to pass it back to Vicki to close out our presentation. But if you have any questions or if you want to contribute any examples, feel free to put an issue out on the GitHub.
Thank you, Jessica. So one resource that you will find very helpful is this helpful GitHub page. This GitHub page is an online resource designed to help our users access, understand, and analyze U.S. Census Bureau datasets. It introduces the structure of census data products, explains key concepts such as geographies and variable naming, and provides practical tutorials using popular R packages, including tidycensus, tigris, and others. The guide walks users through installing required packages, retrieving ACS and decennial census data, handling margins of error, mapping data, and exploring additional tools. It is intended for beginners and experienced R users who work with demographic and socioeconomic data. In closing, I encourage you to connect with us directly. If you have ACS questions or want to learn more, you can visit the ACS website. It is a great place to start. Remember, you can access Jessica's GitHub page to practice mapping using R at the link shown here. You can also visit the Census Bureau Slack channel to submit census data questions. The ACS user support email address and phone number are shown here to get answers to your ACS questions. Please sign up for and manage alerts about the ACS at the link also shown here on the page. You can go to the Census Academy website, which is the learning hub for data skills. On the Census Academy page, you can learn how to access and use Census Bureau data through our how-to data gem videos and in-depth courses, webinars, and tutorials. And one last thing, if you're using ACS data, make sure to source the Census Bureau surveys as to where you receive the data. It helps people know that the information they're using is powered by DACS. Now, we may have a minute to take a couple of questions, so let's just take a minute to see if we have any, a couple of questions from the chat, and we can answer them verbally while we're still here.
Sure. Hey, Vicki and Jessica. We did get a couple of questions. Most of them we've been able to answer, but we do want to remind attendees that these slides are available right now, and we put the link into the chat, and the recording will be posted within the next couple of weeks. So make sure to check that out. And then a question for Jessica, does map view work at the census tract level?
That's a great question. That would be a good thing to test out. I believe so. I believe it will, but I would need to test it to say for sure.
Perfect. And then I think otherwise, I think we're caught up on chat. We were able to answer everything while you were presenting today.
Oh, that's awesome. Okay, so if there are no more questions, this concludes today's webinar. We thank you for your time and attention. Have a great rest of your day.